Good afternoon. We are continuing our lesson on sets. The last time we looked at what sets are, simple and compound sets, and also we looked at how to reduce sets. Today we are going to look at how to add sets, how to subtract sets, how to multiply sets. Before we look at how to add sets, understand that we have like sets and we have unlike sets. When we say like sets, we are saying that sets that have the number in the square root to be the same. So if I have root 2, I have 3 root 2, I have 19 root 2. These are three different sets, and the number in the square roots are all 2. Hence, you see these three sets are like sets. So if you have root 3 and root 27 and root 27, and you are asked if these two sets are like sets, you may just say no, because the numbers in the roots are different. But then you have to be careful. One set is reducible and the other is non-reducible. So once this set is reducible, you have to reduce it. How do you reduce it? You look for a perfect square that can divide 27 without remainder. And obviously it's going to be 9. So that 9 times what value gives you 27? That's 3. So we are going to have root 9 times root 3. Root 9 is 3 times root 3. So 3 times root 3 is 3 root 3. So obviously this set and this set are like sets. Okay. So if you be able to add or subtract sets, number one, the sets must be like. Only like sets can be added or subtracted. If the sets are unlike sets, meaning the numbers in the roots are different, even if you reduce the set, the numbers in the roots will be different. If these two sets are unlike sets, then you cannot add or you cannot subtract. So let's take an example of sets and let's look at how we can add or how we can subtract them. So I have a number like 27 plus root 75 minus root 20. I am asked to simplify this set. How do I simplify this set? I have root 27 plus root 75 minus root 20. Number one, if they are unlike sets, then the answer will be the question. But then if you watch carefully, all these three sets are reducible sets. So you have to reduce them first to be able to find out if they are like sets or they are unlike sets. So we take the first set, root 27. We are going to reduce it. Now in reducing root 27, we are going to look out for one number times a different number will produce 27. One number times a different number will produce 27. Now root 27. So we take a look at what perfect square can divide 27, and that's 9. So root 27 becomes root 9 times root 3. If you take root 75, 25 is the perfect square that can divide 75 without remainder. Times 3 should produce 75. If you take 24 is a perfect square that can do that. Times 5 should give you 20. So now we can now split. We have root 9 times root 3. We have root 25.
We have the elite cause cancer. So they are harmful to
So here we're going to have root 4.
when humans get in contact with this type of hydrocarbons, such as
Times root 5.
they can get a bit get cancer. Yes.
So if you have root 9, that should give you 3.
Okay, so I told you there are a lot of things we learn from this, right? So you had.
Now root 25 is 5.
Yeah, widespread environmental pollutants.
This is 2 times this 5.
That's from fossil fuels.
So 3 times root 3 is 3 root 3.
This
5 times root 5 is root 3 is 5 root 3. Minus 2
another thing. So actually, this
is 5. If you now have 3 root 3 plus 5 root 3, it gives you 8 root 3 because they are like sets. This set and this set are like sets, so we can add. If they are like sets, now how do we add? You add the numbers multiplying the sets. So it's 3 root 3, 3 times root 3. 5 root 3, 5 times root 3. So you add the 3 and the 5, making up 8. Then because they are like sets, you repeat one of the sets, that's root 3 minus 2 root 5. Root 3 and root 5 are not reducible sets. And once they are not like sets, that's the answer. We cannot subtract. So our answer to the question is 8 root 3 minus 2 root 5. Let's take another example.
Organic, they can cause mutation, they are pathogenic, they can cause
2 root 3.
cancer.
So that's 3 root 5 minus 5 root 3
Can be affected by them.
plus 10
Enzymes in the body.
root 5.
Sunlight itself can convert these cells into reactive forms that are toxic. So they can bind to DNA, your DNA.
So if you have this to solve,
this, like I have mentioned,
first you have to group the like sets. So 2 root 3 is like 5 root 3. So we'll group them. So you have 2 root 3 minus 5 root 3. Then you have plus 3 root 5 plus 10 root 5. So if you now have this, the first two are like sets, what do? You subtract the numbers that are multiplying with 3. So 2 minus 5 should give you negative 3. And then with 3. Now we are adding these two. They are like sets. What do? We add the numbers, multiply them with 10, the root 5. 3 plus 10, and that's what? 13 root 5. So at this point, the root 3 and root 5 are non-reducible sets. And the two sets we have are unlike sets. And therefore, that's our answer. Someone else can write the 13 root 5 first. It's not wrong. Then 6 minus 3 root 3. It's the same thing. Let's take some more examples. If you have root 200 minus root 98 plus root 50 plus root 72. And you are asked to solve this. All of these 4 sets that we have, you cannot determine whether they are like sets or unlike sets in this form because all these 4 sets are reducible sets. So the first thing we have to do is to reduce the sets. So how do you reduce the first set? With root 200, we can look at the perfect square that can divide it. And if you take the perfect square. 4 can do 4 times 50. If you go further, I think after 4, we can have others. But the highest we can have is 100. So always use the highest. So root 100 times 2. For 98, if you think deeper, you see it's 49 times 2. 50 is 25 times 2. 73 is 36 times 2. So if you reduce that, that will be 10 with 2 for the first one. 7 with 2. 5 with 2. 6 with 2. I'm getting the 10 because root 100 is 10. 10 is 100. I'm getting the 7 because root 49 is 7. 7, 7, 49. I'm getting the 5 because root 25 is 5. 5, 5, 25. I'm getting that 6 because root 36 is 6. 6, 6, 36. Now I realize that all these 4 sets are like sets. So we are going to solve them. We can solve. So how do we solve this? The answer will always be root 2. So we'll have the numbers multiplying 10 minus 7 plus 5 plus 6. All of these root 2. So 10 minus 7 is 3, plus 5 is 8, plus 4 is, plus 6 is 14, root 2. That will be the answer to this question. So in a nutshell, if you want to add or subtract sets, the sets must be like sets. What are like sets? Like sets have the same numbers in the square roots. And sometimes if they are not the same in the square root and they are reducible sets, don't be in a hurry to say they are unlike sets. Reduce those sets first. If you reduce it to the point where it is non-reducible and the numbers in the sets are different, then you can conclude they are unlike sets. If the sets are unlike sets, you cannot add or subtract them. If the sets are like sets, then you can add or subtract them. How do you add like sets? You add the numbers multiplying the sets. Then you repeat one of the sets since they are the same. So if you have root 3 plus 2 root 3, these sets are like the number multiplying this is 1 plus 2 is 3. Then repeat on the set with 3. We have 3 root 3 or 3 root 5 minus root 5. These are like sets. So the numbers in front or multiplying the root 5 are 3 and then 1. So we subtract them 5. So your answer here is 2 root 5. That's how to subtract these sets. So widespread and invisible. This includes organizations and also massive now let's look at how to multiply and then divide sets. How to multiply and divide sets. Before we look at how to multiply sets, what you should notice is that if you have a square root, a set times itself. Okay. In fact, if you have to solve this, you can bring them together, and that will be 3 times 3 within a square root. And 3 times 3 is 9. Square root of 9, 9 is a perfect square, and the answer is 3. So if you watch carefully, We can say if you have square root of 3 times square root of 3, the answer is the number in the square root 3. So if you have square root of 5 times square root of 5, don't struggle to solve. 5 times 5, 25. Before you know it is 5. Once the numbers in the roots are the same, the answer is the number in the root. Don't forget, this can also be written as with 7 squared. If you see with 7 squared, don't forget it means with 7 times with 7. And the answer is 7. So that's the first thing you have to do. If the numbers in the square roots aren't the same, root 3 times root 5, what happens is that when you solve, you put them inside one root, and the answer becomes root of what? 15. That is how to multiply sets. So let's take an example. Let's say I have root 3, open bracket 2 plus root 5, close bracket. Now, if you are going to solve this, the last thing I have to say I've forgotten is, if you have a number times a set, the answer is bringing the two together, the number set. If you have 5 times with 5, the answer is 5 with 5. If you have 3 times with 3, 3 times with 5, the answer is 3 with 5. You bring them together. So if you are going to solve this, don't forget the distributive property. So the root 3 will multiply the first number or the first term inside the brackets. Then the root 3 again will multiply the second inside your brackets. So if you have root 3 times 2, it's a set times a number, the answer is bringing them together, 2 root 3. If you have root 3 times root 5, you bring them all under one root. So the answer becomes 2 root 3 plus 15. And that ends it. You are done multiplying the sets. If you have 2 plus root 3, 3 minus root 3, and you are asked to solve this, we can still use a distributive property where we take everything in the first to multiply each of the terms in the second. Or you can take each of what is in the second to multiply all in the first. I'll do both approaches. You choose what you are okay with. So if I take everything in the first, so it means I'm going to have 2 plus root 3 multiplying the first, which is 3. And I'm going to also have again 2 plus root 3 multiplying the second, which is also negative root 3. I can arrange it such that the terms in the brackets comes after the single term. So I can say it is 3 into bracket 2 plus root 3. Then I have minus root 3 into brackets 2 plus 3. I rearrange because their multiplication is commutative. I don't think this is 2 plus root 3 minus root 3. No, it's 2 plus root 3 times minus root 3. Okay. So you move 3 times 2. I multiply 3 times 2, and that gives me 6. Then 3 times root 3, a number times the set, and that's the number and the set being brought together. When we come to the next side, negative times positive should produce negative. Then root 3 times 2 should be 2 root 3. Negative times 4 should give you negative. Then root 3 times root 3 should give you 3. We just said set times itself is the number in a set. So if I group, I'm going to have 6 minus 3.
Is a carbon state, right? And they are bleeding with
I'm going to have 6 minus 3.
that from decimal mentioned.
Then plus 3 root 3
one which is clearly
minus 2 root 3.
Major question.
6 minus 3 is 3 plus 3 with 3 minus 2 with 3 is 1 with 3. Subtract 2 minus 3. They are like sets. So subtract the numbers multiplying. 3 minus 2 is 1. So 1 with 3, but you don't write the 1. So if you have with 3, it means 1 with 3. So just write 3 plus root 3. And that ends the solution to this. So in very simple terms, if you are multiplying sets, know that a set times itself will give you the number in the set. Two different sets multiplying, you just put each of them within one square root. A number times the set is bringing the number and the set together. And that is it. So let me take another example with 50 times root 49. Sorry. 50 times root 98. One way of solving this is putting all within one square root. And you see the numbers within the square root are huge. If you do that, your calculations will be very lengthy and you may not be able to finish. Now, these numbers within the square roots are reducible. So we reduce them. That makes it easier to calculate. So you have root 25 times root 2 for the first one, times we have root 49 times root 2.
So two expressions are exactly.
So root 25 is 5 root 2. And half times 7 root 2. Now, if you have this, in fact, don't forget the 5 root 2 is like 5 times root 2 times 7 times root 2. So you can decide to multiply the 5 and the 7, making up 35. Then you have root 2 times root 2, which is 2. 35 times 2 should give you the answer 70. It's easier this way than multiplying what's in the roots. So if you have something of this nature, you reduce first before you proceed.
Yeah.
Let's look at how to divide sets. How do we divide sets? If you are dividing sets, number one, understand that sets cannot be denominators. If a set is a denominator, there is a way of going about it. You have to rationalize. Now, how do you rationalize? If the denominator is a one-term expression, you multiply the fraction by the same denominator. What am I talking about? If I have 2 out of 5, sets cannot be denominators. So if a set is a denominator, we are going to rationalize.
Universities and colleges because they do not know what's on the YouTube. And you can give them your preferred course. This is here to solve them for their things. This is second. We have to be 70.
2 over 5 times number. What's the one-term expression? I multiply by with 5 by with 5.
Put in the details, add your grades, choose your preferred courses, and then they will tell you whether you qualify or not. This will give you the confidence that the school you're applying to should really qualify. Shake off the worry and the financial stress with admissions today. today's world, taking care of your employees, it means that you have to
If you now have this, we're going to have 2 times 5 out of 5 times with 5. Top times top down times down. The 2 times with 5 is going to give you 2 with 5. The number times the set. Then with 5 times with 5, the number in the sets are the same and they are multiplying. So then answer becomes the number in the set. That's it. I've been able to simplify. And now there is no set at the denominator. Another example, let's say I have 3 over 2 root 7. Now there is a set at the denominator. I'm going to rationalize. Before then, it's one term expression at the denominator. So I'm going to just use the set. It's going to be root 7 out of root 7. So top times top, I'm going to have 3 times root 7 out of denominator times denominator, 2 root 7 times root 7. I'm going to have 3 root 7 as my numerator. And the denominator is more like 2 times root 7 times root 7. I'm going to have the 2. And then root 7 times root 7 is 7. Same number within the set, multiplying the answer with the number in the set. I'm going to have 3 root 7 out of 14. And that ends it for this particular one. So, what if there is 2-term expression as your denominator? Let's say you have 2 out of root 3 minus 5. And you are asked to rationalize this. Once the terms are 2, note it, you are going to multiply by root 3. Once it's minus, you use plus. Root 3 plus 5. So if you now have that, 2 times now, that's a 2-term expression, put that in a bracket, root 3 plus 5. Then down I have root 3 minus 5, root 3 plus 5. We are going to expand the numerator 2 times root 3, root 3, 2 times 5, 10, all out there. Now the denominator, I'm going to take first multiply each of the second. So root 3 times root 3 is 3. Then root 3 times negative 5 is negative 5 root 3. Then everything here times the second one, 5. So 5 times root 3 is 5 root 3. Then 5 times negative 5 is negative 25. So if you proceed, you're going to have 2 root 3 plus 10 all out of. If you have negative 5 root 3 plus 5 root 3, that goes to 0. But next 5 plus 5 is 0, next 2 plus 2 is 0, next 10 plus 10 is 0. So negative number plus itself is always 0. I'm going to have 3 minus 25. So that's 2 root 3 plus 10 all out of next 22. So that should be 2 root 3 plus 10 all out of negative 22. So you can decide to split to make it the solving easier. So it's 2 root 3 out of negative 22 plus 10 out of negative 22. That's root 3 out of negative 11. Negative, don't stay down, bring it up. So negative 3 out of 11. 5 out of 11. So negative, turn it up. 5 out of 11. So someone who can say our answer is negative root 3 minus root 5 all out of 11. That is how to rationalize set. So if you were to be 2 out of root 3 plus root 5, so multiply by, we take the same root 3, but the sign becomes the other one minus root 5. So root 3 minus root 5. So the top 1 term times 2 terms, 1 term times each of the 2 terms. So that's 2 times root 3, 2 root 3, 2 times root 5, 2 root 5, all out of. Now I take this times this, root 3 times root 3 is 3, root 3 times root 5 is negative 3, 5, 15. Root 5 times root 5 is also root 15. Root 5 times root 5 is 5, but it's minus, plus minus is minus. I'm going to have 2 root 3 minus 2 root 5 out of 3 minus 5. If what with 15 plus 15 will go to 0. So 2 root 3 minus 2 root 5 out of negative 2. So negative don't stay down, I can bring it up. That's negative multiplying 2 root 3 minus 2 root 5. All out of 2. I can factorize 2 out. So negative 2 out root 3 minus root 5. All out of 2. So negative times root 3 is negative root 3. Negative times negative root 5, that's plus root 5. So you can see our answer is root 5 minus root 3. You want to. That's it. Okay. We have one more lesson on set student. I wish you a very wonderful holiday. Have a nice day. We'll have a lot of questions to practice under this when we return to school tomorrow. Bye bye.